all you got to do for me today, first we will condense. So what this means is to write it as a single logarithm. So you'll notice right now it's like all spread out, and so your goal is to get it back into one piece, into one logarithm, okay? We will simplify it if possible. So if you look back at your rules from yesterday, look at the power property. The power property says if you have a number out in front, it can be written as an exponent. And so on number 19, you have the 2 out in front. Previously, that was an exponent. And so now you're going to take that little 2 and you're going to bop it back up on the 6, right? So now we're going to rewrite it. The goal is to squish it back together, make it into one logarithm. So log of 6 raised to the second power minus log of 9. And there are no bases here. It's a base 10 problem. Okay, you can simplify that a little bit. What is 6 squared? 36. And we're going to keep going. Now, when I see subtraction, I know that it means to divide. Okay, so if you look at your rules from yesterday, if you don't remember, on page 11, that is the quotient property, which says that if I have division, I can split it with subtraction. So if I'm going backwards, I can put it back together with division. So I can rewrite this as the log of 36 divided by 9, which is, of course, what is 36 divided by 9? 4. So it becomes log 4 as the final answer. You can take as many steps as you want to simplify this down. We're just rewriting until we get done. We'll do some together and then you'll try a few on your own. Number 21. This time you got some variables, but again, you have like numbers out in front, which tells you, hey, those should be exponents, so bop them back and put them back as exponents because you are trying to condense it and put it back into a single logarithm. Right now it is spread out. We're trying to undo that. So it becomes log base 4 of u to the 7th minus log base 4, and it's v. It already had an exponent there, so you are going to multiply it. So because that 3 was out in front and there was already an exponent of 2, you have to multiply it to the one that was already there, which will become obviously v to the 6th. When I have, when I have subtraction, what do? You can divide to put it back together. So it becomes this, log base 4, and then we've got u to the 7th divided by v to the 6th. Can I simplify that? Are they the same base? No. So you're stuck. And that is it. Okay, we're going to start the next one, number 23. We're not going to deal with, we'll deal with these first two. So when you have something like this where it's got 3 logarithms, you just go left to right. It doesn't actually matter which 2 you do first. It's totally up to you. But I'm going to deal with these first 2. So I see addition. What do I do when I see addition? Multiply. So I can rewrite it as log base 3, and I'm doing 4 times y, which is just 4y. Then you see 1/2 out in front of the other one. So please bop it back and make it an exponent. So it becomes log base 3 of 49, now raised to the 1/2 power. And we'll talk about what to do with that after lunch. So if I take the square root of 49, I'll write it out the side. Square root of 49 is what? 7. Okay, so that's going to become log base 3 of 7. Again. Let's see if I can stretch it out. Oh, that's why it's not charging. That's not like it. Okay. So let's write it out again. So log base 3 of 4y plus log base 3 of 7. And then when I see Addition. What operation is that? I multiply them. So multiply those two, 4y times 7. What would I get if I do 4y times 7? Good job. There you go. One more together. I'm not going to do 24 for you. I'll have you do that in a second. We're going to do number 25. Okay, so I've got this 3 out in front, drop it back. It gets to become an exponent when I condense it, so it becomes log base 2 of 4 to the third minus log base 2 of 32. Okay, you can use your perfect chart or you can use a calculator. We need to know what is 4 to the third power. 4 times 4 is 16, times 4 is 64. So log base 2 of 64 minus log base 2 of 32. Okay. When I do this, when I have subtraction, what do? Oh, sorry, that's not a highlighter. Divide. So I'm going to do log base 2 of 64 divided by 32. What is 64 divided by 32? 2. So you get log base 2 of 2. And I hate to break it to you, that is not the final answer because you can evaluate this. Remember logarithms we talked about earlier this week. This is equal to x. So if I write this in exponential form and loop-de-loop around, 2 to what power is 2? 1. Yep, 1. So you can actually evaluate that whole thing. Another way to think about it, you would do log 2 divided by log 2. It would also give me 1 if I do change of base. Okay? So you've got 4 left here. I'll give you some guidance on number 24. On number 24, hopefully you see there are parentheses, okay? So you need to deal with what is inside the parentheses first because PEMDAS, that's what order of operations says. Parentheses goes first. So you need to make sure you do what's inside the parentheses first when you get to number 24. So show the work to get there. If you see a number out in front, you need to bop it back as an exponent, okay? We'll put the final answer up here. You need to show more work than this. Okay, there are the final answers. So if you look at number 24, we first do what's in parentheses because that's what order of operations says to do. If I see multiplication, or sorry, if I see a plus sign, I know to multiply. So it becomes this. 1/3 stays out in front of this guy. And then I multiply 8 times 27, which gives me log base 5 of 216. Okay, because you have a number out in front, this is a difficult one, pay attention. If you are stuck on it, put that 1/3 back up to the top. It becomes log base 5 of 216 raised to the 1/3 power. And I'm just rewriting the second half. When I take it to the 1/3 power, that is the same thing as doing what kind of root? The cube root. And so the cube root of 216. And by the way, you can type that in your calculator, 216 to the 1/3, but that is 6. So that is log base 6, sorry, log base 5 of 6 divided by 3 because subtraction tells you to do division. And that is how you get log base 5 of 2. Is it difficult? Yes. Do you need to do one piece at a time? If this is not enough space, if you need like more space, then you could do it on the side or something like that. Or if this is your assignment, make sure you've got plenty of room. Okay, a lot of us were stuck on number 26. Make sure you're just doing 2 at a time. So I'll start with log base 10 of 6 raised to the second power minus log 16 raised to the 1/4 power. I'll go ahead and write down log 3, but we're not going to do anything with it yet. Okay, we got to figure out what these numbers are. Hopefully you've got 6 squared is 36. And then I am taking the 4th root of 16, which is 2. And then you can just start combining left to right. Do 2 at a time only. So if I do this one, I'm doing log, this is subtraction. So I do what when I see subtraction? Divide. So 36 divided by 2 is 18. And now we'll add the log 3. When I see addition, I multiply. So if I multiply those two, then that's how I get log 54. There is not one right way to do it. I would just encourage you to try and do one thing at a time, rewrite. Do one thing, rewrite, until you have it simplified all the way. This is the same exact thing, except now we go backwards, right? So now I'm going to spread it out into separate logs, because right now it's in one logarithm. You need to look at this and decide, okay, what operations do I see, and then how do I spread it out? I've got x, y, and z all next to each other. When they're all right next to each other in math, what operation is it? Multiplication. So you would spread it out with addition. You can look at your chart from yesterday. So log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. But you don't want to leave it like that. You need to, anytime you have an exponent, because what we're doing is expanding it on this one, going the opposite way, we're trying to spread it out further. I'm going to bop that 4 forward and rewrite. Okay, so this all stays the same. Wow, plus log of y plus that 4 is in front, log 6 of z. Okay, that will be your final expanded form. I'm not going to put a box around it. It's too long. Number 30 is a fun one. Yeah, that's how you know it's going to be good, right? You have it power to a power. When you have power to a power, I would say the easiest thing to do is distribute that exponent first. Sorry, I'm zoomed in, so you can't really see my lines I just drew. Distribute the exponent and rewrite it as log base 2 of, it would become y squared over, do you know what you do when you distribute? The exponent you multiply. So it becomes z to the 10th because you're doing 5 times 2. And now please think about it for me. I have division, so how do I spread it apart? Subtract. Okay, so log base z, not z, what is it, 2? I don't know. This is why I usually write the lines through my z's. Y squared minus log base 2 of, this is actually a z, z to the 10th. Because you have exponents, bring those out in front, and then you should be done. So 2 and 10 need to come out in front to expand it or spread it out. Oh, no more exponents. Okay, and then log base 2 of z. You're doing great. Ready for the last example ever? Okay. Look at number 31. It is raised to an exponent, but you do not see it. Like, yes, x is raised to an exponent, but there is an exponent there because it has a square root. So what I mean by that is that you could rewrite this as 7x to the third raised to what power? Not to the second power. It is a square root. It is raised to 1/2. And again, this is on the wall. So now, just like the last one, distribute that to both of the bases there, and it would become log. And then it's got 7 to the 1/2 power. Okay, you have x to the third, so you're doing 3 times the 1. It gets multiplied to the top, becomes x to the 3/2, if you know how to multiply fractions. Then think about for me, okay, these two are side by side. What operation do I see? Multiplication, so split it with addition. Can you see if we can finish that one? The exponents come out in front, and then split it with addition. I'm going to do this in one step. But of course, you could always do it in multiple steps. The more the merrier. I don't care how long it takes you, as long as you get there in the end. Okay. Check your answers once you think that you have them here.